Section 7.4, Newton's Law of Cooling. So if you take something that's warm and set it into a cool environment, over time, that warm object will cool off. The rate at which that object cools is proportional to the difference in temperature between the hot object and the cool environment. This is what's known as Newton's Law of Cooling. This is another contribution of Isaac Newton. So the rate at which something cools depends on how much difference there is in the temperature between the object and the environment that you put it in. For example, a hot pie will cool faster if you stick it in the fridge than it does if you leave it out on the counter. This is because there's a bigger difference between a hot pie and a cold fridge than there is between a hot pie and the general room temperature. This law also applies for when something is heating up. If you take something that's cooler than its surroundings and stick it into a hotter environment, that object's going to heat up to the temperature of the hotter environment at a rate proportional to the difference in temperature between the two. The hotter the environment, the faster that object's going to heat up. This only doesn't apply if you have some source of energy, so some type of engine or a motor, or something that is providing electromagnetic waves like a microwave. So Newton's law of cooling really is the proof against an old wives' tale, which is that hot water freezes faster than cold water. You hear this often. In general, this comes about from the way that the plumbing in some houses work. When you have hot water pipes generally stay stagnant and at rest more often than your cold water pipes, because you use cold water for everything and hot water not for everything. So because they're stagnant in the cold without that water moving, they tend to sometimes freeze before your cold water pipes. That does not mean that hot water freezes faster than cold water. I mean, you could do this. You could take hot water and cold water and stick it in ice cube trays and stick them in the freezer and see which one becomes ice first. But I think you'll understand that the cold water freezes first. But you can prove this using Newton's law of cooling, knowing that the rate at which it cools or freezes is relative to the difference in temperature. If you have that hot water has to cool down until it reaches the temperature of the cooler water first before it can freeze. That amount of time is going to be longer than the amount of time for the cool water to freeze, because then you have to have the hot water get to the cold water point before it gets to freezing. And so those last two times are going to be equal, and the hot water still has to get there first. So the idea that hot water freezes faster than cold water is just not true.